Hello everyone, welcome to my channel, and today we will solve a very popular bit manipulation problem, that is power of 2, right? And instead of using loop or division, we will solve it using a super smart bitwise trick in because one-time complexity. So basically we have given an integer n. We need to check that whether this number is power of 2, and if it is power of 2 we're going to go with true, otherwise we're going to go with false. So now let's see how can we solve this. So basically we have this key observation, we have these numbers and their binary form. So these numbers are actually valid number, these numbers are actually power of 2, means 2 to the power 0 is actually 1, 2 to the power 1 is 2, 2 to the power 2 is 4, and so on. So the thing that we need to observe is their binary form, right? If you're going to see their binary form, you're going to see only one set bit in it. Here also we have only one set bit. One set bit means only one integer present in it, right? So we have whenever, so we can say that whenever we get a binary number, and if we get only one set bit, or if only one set bit present in it, so that number is actually power of 2, right? So this is what the observation is, right? So how can we identify that a binary number having only one set bit? So for that we're going to perform some of the exercise. So let's suppose if we have an integer, any random number, right now I'm just taking 8, and we have n minus 1, right, which is 7, right? And we're going to perform the bitwise and operation on them. So if we're going to do this, so what the output is going to be? So if we're going to perform the bitwise and operation, so basically we get 1 0 is 0, and again we get 1 0, again we get 0, 1 0 is 0, and 1 0 is 0, right? And now let's move to the another example. We have n is equals to 16 and we have n is equals to 15, means we have n or n minus 1, right? So we are just performing a bitwise and operation in between n or n minus 1. So we are going to get basically 1 0 is 0, and then again we get 1 0 is 0, 1 0 is 0, 1 0 is 0, and 1 0 is 0, right? So whenever we are taking integer or their n minus 1 integer, so we get 0, again we get 0. And now here we have integer, let's suppose 6, and we have n minus 1 is 5. And now let's do the let's calculate the output. 0 0 is 0, 1 1 is actually 1, and 1 0 is 0, and 1 0 is 0. So here we come to know that if we are taking an integer, and that integer is actually a valid integer, means that integer is a power of 2, right? 8 is a power of 2 and 16 also a power of 2. So in these two cases we get the output equals to 0, right? And if we're going to taking n is equals to 6, which is not a power of 2, so in this case we get an output which is actually greater than 0, right? So here we come to know that whenever we're going to get the output equals to 0, when we're going to performing in bitwise AND operation between two operands, which is n or n minus 1. So if it is 0, so we get the valid number, which is actually the power of 2, and we're going to go with the true, right? So that's why we need to understand this key observation for it, right? So now let's see the code. So basically, first of all, we want that the n or that integer should be greater than 0. So we're going to mention that case also. So if n is greater than 0 and And we know that we're going to perform the bitwise AND operation between n or n minus 1. So I'm going to write over here n, the bitwise AND operator between n minus 1, n minus 1. And if it is 0, if we're going to get the output is equals to 0, so we actually get the valid number, or we have that n is a power of 2, right? So in that case we're going to go with the true. So true, we're going to write over here true. And in else condition we're going to go with false. So I'm going to write return false. Yes. And now let's run this. Accepted. And now let's submit this. And that's how we can check whether a number is a power of 2 using a bit manipulation trick in constant time. So if you enjoyed this explanation, make sure to like this video, and I'm going to see you in next problem. Bye bye.